The bearing of a ship from a lighthouse was found to be north 14 degrees east, and after the ship sailed for 9.3 miles due south, the new bearing was north 30 degrees east. Find the distance between the ship and the lighthouse at each location. So what we're gonna do, we're gonna translate everything mathematically, sentence by sentence. So the bearing of a ship from a lighthouse was found to be north 14 degrees east. So what we're gonna do, we're gonna draw a plane like a coordinate system, and we'll call here the north. This is gonna be the east. This is going to be the west, and this is going to be the south. So when they say, so here the center will be the lighthouse here. So when they say the bearing of a ship, so the bearing is the deviation from the north. So how do you deviate from the north is your bearing. So they're saying the bearing it was found to be 14 degrees north, so north and then east like that, 14 degrees. So the deviation from here to here is 14 degrees. So let me represent it. So it's going to be deviation is 14 degrees like that, 14. Now next they're saying that after northeast, so we're in northeast, so we're here. If it was northwest, it would have been drawn on that side, but northeast, and then we deviate on that side for 14 degrees. And so the ship is somewhere around here like that. So this is your ship. The distance from here to here, we don't know it, but the deviation from the north is 14 degrees northeast. Now after the ship sailed 9.3 miles due south, so going on the direction that is so you're going to the south, like that. So you sail the distance from here to here, you're still in the north, so the distance from here to here is 9.3 mile. So after sailing 9.3 mile, you end up being still in the north. Let me continue drawing like that. So you're still in the north, and your new bearing, so the new deviation from the north, the deviation from here to your new location is about 30 degrees northeast. So from here to here you have an angle of 30 degrees. Now your the new distance is actually 9.3 miles. So from here to here 9.3 miles. So the question is, what's the distance from the lighthouse to the ship? So here this is the ship initial, so I'll write initial, and the ship final. Let me write fi, final. So the ship at those two locations, so we want to find the distance from here to here, and then we want to find the distance from here to here, knowing that the angle here is 14 degrees and the angle from here to here is 30 degrees. Now with the information that we have, what can we find? We know that this is 14 degrees, and the angle from here to here is 30 degrees. So we can find the small angle that is here. That small angle is actually 30 degrees minus the 14 degrees that is here. So 13 minus 14 is actually 16, but yeah, so 16. So the angle that is here is 16 degrees. Okay, now we need to figure out what's the angle. So first step, we try to figure out the angles. We don't have enough information, we only have one side, and this shape looks like a triangle. As you can see, this is like a triangle. So we need to figure out what are the angles of our triangle. So the first angle is 16 degrees. We need to figure out this angle and that angle, and then we'll have a complete triangle. So this one is 16 degrees. How about this one? How do we figure that one out? Looking at this graph, this picture, we notice that notice something. Here we have two parallel lines. When you have two parallel lines and a line that is separate, that is cutting through those two parallel lines, the angle that is here on that side is the same as the angle that is on this side. So, and this is our alternate interior angle, alternate interior angle. So this, see, if this one is 14, then this one is also 14 degrees. So we notice that this line that is here is parallel to that line that is here. So those two lines are parallel and they're separated by a line just like the one that we have here, and the angle that is here is 14 degrees. So the angle that is here, because they are alternate interior angle, is also 14 degrees. So this angle here is 14 degrees just like this one, following the property of alternate interior angle. So this one is 14 degrees as well. So we need to figure out the last one that is here. So we have like a triangle. The sum of all the side of the angles of the triangle is 180 degrees. So 180 degrees minus 14 minus 16 degrees should give us the remaining angle that is here, and that's gonna be 150 degree. 150 degrees. So the angle that is here is 150 degree. So now we have a triangle with we can call, yeah, so we have a triangle. I can redraw this thing as a triangle. I can redraw everything as a triangle like that, with angle 16 degrees here, 14 degrees here, 150 degree here, and we can label every side. I can label here A, B, C, small a 9.3, small c here, and small b here. So I can use now the law of sine. So according to the law of sine, I know that a divided by sine of a equals to c. I'm looking for the initial here. So the sheep initial distance. So I'm looking from here to here, that length, and that's the same that is here. Let's call it c. So c divided by the sine of c. So actually what I did, I'm redrawing everything on that side to make it look like a triangle and work easily with it. So c divided by c. So I'm looking for small c. So small c, a divided by sine a multiplied by sine of c will be equal to small c. I know that a is equal to 9.3 divided by sine of a, 16 degrees, multiplied by sine of c, which is 150 degrees, and that is going to be equal to small c. Take my calculator. So it's going to be 9.3 times sine of 150 divided by sine of 16 degrees, and that is that, and then we have to round it to the nearest 100th mile, so it's like 2 decimals. So second round, second answer to 2 decimals, and I get that. So 16.87. So the length of c is gonna be 16.87. Now I need to figure out I need to know the distance. So so this is the distance from here to here. So we need to figure out the distance between the lighthouse and the ship in the final position. So that means that side of the triangle. In other words, it's like I'm representing this side as this one in here. So from here to here, based on the same law of sine. So a divided by sine of a is equal to b divided by sine of b. So b divided by sine of b, and I'm looking for b, the distance from here to here. So a divided by sine a multiplied by sine b will be equal to small b. So 9.3 divided by sine of 16 multiplied by sine of b, which is 14 degrees, will be equal to my b. So b will be equal to, take the calculator, 9.3 times sine of 14 divided by sine of 16. I get that. So math, round that to 2 decimals, and I get 88.16. And that's my final answer. So that's how you do to figure out the different angles.